let's put this research in context. I've put a map of Europe there, and just if you look, zoom in, we've got a tiny island called Malta right in the middle of the Mediterranean. It's a subtropical climate, and quite representative of the climate there. So, glare is a big issue there. You can see typical examples of facades currently being developed. Of course, the design is questionable in terms of window-to-wall ratios in that climate. So we were looking at what adaptive glazing technologies we have presently. We are familiar with PDLC and SPD technologies in different applications in automotive and aviation industries. And we said, okay, how can we combine, or what happens if we combine both technologies in the same laminate, or even better, the same IGU, to give us the properties, both advantages, both films, for the benefit of clear control. This part of the study tackled scale model assembly testing, representative of a 5x4 by 2.6 room with a glazing ratio of 56%. And the idea was to take snapshots with a DLSR mimicking the occupant view. Static glass-based samples we have identified for commercially available glass panes having the VLT between 20 and 70%, using these as our base measurement. Laminations were done first separately, solar PDLC laminate and an SPD laminate, giving us visible light transmittance range of 1, 73, and 0, and 45. We tested separately, and we have then laminated a combined single laminate with both technologies, shown in the photo on the left. And to represent the IGU, we decided to place both laminates on top to see what happens, to see measurement of the results. The first test that we ran was visual appearance tests, comparing a set of photos with a 180-degree fisheye lens, facing directly the sun, to get an idea of the view to the building document. And as one could see, the combination of both technologies can give nearly a complete blackout effect. So the sun is no longer visible, the solar disk is, but you can literally look at the solar disk without irritating the eyes. We carried out glare measurements using the DGP metric and K mobile luminance photometer, and the idea was to generate luminance maps as shown in the slide. Again, we had 16 combinations comparing on and off combinations of both switchable glazing, and certain observations could be immediately deduced. Solar PDLC film on its own appeared to have a dispersion effect, whereas the SPD on its own wasn't enough to control the glare to the level that we were aiming for. But the combined version, both the laminate and the overlaid, in our view, gave a very good range of DGP measurements. The 16 results were plotted on this sheet, and as one can see, the PDLC on its own exceeds the mathematical limit for DGP, which is from 0 to 1, whereas the combined switchable glass gave us a very good indication of glare control combined with privacy. Because privacy is something that we sometimes underestimate, the need for privacy, and we believe that we can achieve both targets. We measured also mean luminous intensities within the light source containing the solar disk, and the combination of both technologies, as one can see, gave a very high mean luminous intensity due to the small size of the solar disk. So even though it was brighter, the mean value mathematically was brighter. It was much more comfortable to the naked eye with both technologies combined. The next test that we ran was the measurement of the solid angle of the light source subtended by the solar disk, and the range speaks for itself, comparing the static glazing range with a practically zero solid subtended angle with the combination of these technologies. So the fact that we have a complete blackout effect and the single glazing can give us a wide range between 0 and, let's say, 4 to 5% VLT, of course, converts a facade from an element which is static to something which is dynamic, which effectively we can switch a wall to become a window and vice versa at the touch of the button. Thank you.
Okay.